as we said, that at constant speed, acceleration is equal to 0 meter per second square. Fk, which is the friction due to the kinetic, is equal to mg sine theta. And R, which is a normal reaction here, is equal to the values of mg cos theta. So, but we consider that frictional force due to the kinetic motion is equal to coefficients of static due to the kinetic motion times normal of reactions, or times normal of reactions. We make Wk as subject. Once we make mu k as the coefficients of kinetic motion as a subject, what we get? We get that the coefficients of static motion, of kinetic motion, is equal to frictional force divided by normal reactions. So, due to the constant speed, at constant speed, we said that at constant speed, acceleration is equal to 0. Same because the change of velocity is equal to 0, divided by time, we get 0. So the coefficients of dynamic is equal to mg sin theta divided by mg cos theta. Hapa tunaona kwamba tunajua kwamba coefficient of static friction or coefficients of dynamic friction ni sawasawa na frictional force due to the motion divided by the normal reaction. So coefficients of kinetics or dynamic motion is equal to mg sin theta, which is the frictional force due to the dynamic, divided by the mg cos theta, which is normal reactions due to the motions. As you see here at the diagrams. So, since the mg sin theta divided by mg cos theta, mg and mg are cancelled out. So mg and mg are cancelled out, and coefficients of static friction becomes sin theta divided by cos theta. So the coefficients of dynamic is equal to tan theta. Therefore, at constant speed, kwa mantiki hiyo sasa, at constant speed, katika speed ambayo ipo constant, tunasema kwamba coefficients of kinetic friction or coefficients of dynamic friction is given by the formula which is equal to tan theta. So whenever you see the coefficients of kinetic frictions is equal to tan theta. When a body is at rest, from previous we see when the body is at the speed or at the motions. Consider a body is moving in an inclined plane. We see that the coefficients of dynamic frictions of that body is equal to tan theta. Now let us look at the rest. When the body is at the rest on inclined plane, wakati kitu kikiwa kimetulia pale kwenye inclined plane, kinakuwa katika hali gani? Coefficient of static friction or coefficients of static friction yake inakuwaje? Sasa tunasema kwamba acceleration wakati kile kitu kinapokuwa kipo kwenye inclined plane, kikiwepo hapa, hichi kitu kikiwepo hapa na hakimove kuelekea popote, maana yake sasa tunasema hichi kitu, tunasema acceleration yake ni sifuri. Acceleration ni sifuri. Why sifuri? Ni kwa sababu hichi kitu kimetulia. Maana yake change of velocity ni zero. Since the change of velocity is zero, acceleration is equal to change of velocity divided by time. So once we change the velocity is equal to zero, zero divided by t, we get zero. So once the body is at the rest, acceleration is equal to 0 meter per second square. The frictional force of the body when it is the rest is equal to mg sin theta. And the frictional force and the normal reaction of the body when it is the rest is equal to mg cos theta. But frictional force is equal to coefficient of static friction times normal reaction. Make the subject coefficients of static friction. Once we make the subject the coefficient of static frictions, we get the frictional force divided by normal reactions. This is what we call coefficient of static friction. So the coefficient of static friction is equal to frictional force divided by the normal reaction. So the coefficients of static friction is equal to mg sine theta divided by mg cos theta. This is derived from this above. So the mg and mg are cancelled out. Once mg and mg are cancelled out, the coefficient of static is equal to sine theta divided by cos theta. Since the sine theta divided by cos theta, we get tan theta. So the coefficients of static friction is equal to tan theta. So when a body is at the rest, the coefficient of static friction is obtained that is equal to tan theta. So therefore, at the rest, the coefficient of static friction is given by the formula coefficient is equal to tan theta. Look on example. We have an example which states that a mass is placed on inclined plane. There is a mass which is placed on inclined plane such that it can move at constant speed. That mass can move at constant speed. When the slight tapped, if the angle of the plane make with the horizontal plane is 300, it means kwamba ni 300. Find the coefficients of kinetic Q. Ni kwamba kulikuwa kuna mass fulani ambayo hiyo masi imekaa pale kwenye inclined plane. Ile masi ilivyo katika inclined plane, ile inclined plane ilitengeneza angle ambayo ile angle yake ilikuwa ni angle ya 300. Sasa tunaambiwa tutafute coefficients of kinetic friction. So coefficient of kinetic friction itakuwa namna gani? So we have data given. The data given, we have provided angles of the plane. Tumepewa angle of the plane ambayo theta is equal to 300. Coefficients of dynamic friction itakuwa kiasi gani? From the formula previous, we say that the coefficients of a body at the rest is equal to coefficients of static friction is equal to tan theta. And that's coefficients of dynamic frictions is equal to tan theta. So according to our questions or our examples, we use the formula that from the coefficients of dynamic frictions is equal to tan theta. We apply tans of tan ya 300, tutakuja kupata coefficients of dynamic friction is equal to 0.56. Then there is another example. There is a block of mass of 270 kg is pulled along a horizontal surface. There is a horizontal surface and the mass of this was pulled along that horizontal surface. If the coefficients of kinetic frictions between the block and the surface is 0.4, what is the frictional force acting on the block as it is slide? So you can see kwamba hapa kulikuwa kuna masi ya 270 kg ilikuwa inavutwa at horizontal surface, kwenye surface ambayo ipo horizontal. Wakati inavutwa, ikiwa the coefficients of kinetic friction between the block and the surface ilikuwa ni 0.4, coefficient of static frictions ilikuwa ni 0.4. Sasa tunaambiwa what is the frictional force acting on the block as it slide, kwamba frictional force ambayo itaakti kwenye ile block itakuwa kiasi gani. We have a data given from here. The mass of block M, which is equal to 270 kg. Thereafter we have a normal reactions. What we obtain normal reaction? Normal reaction tunaipataje? Tulisema normal reaction is equal to mg or weight of the body, ambapo ni sawasawa m ni 270 times g ambayo ni 10 newtons per kilograms. Once 270 times 10 newtons per kilograms, we get 2700 newton. This is the normal reaction. So the coefficients of kinetic frictions which we have provided was 0.4. Kinetic frictional force it will be kiasi gani? Kwamba coefficient kinetic frictional force hapa itakuwa kiasi gani? So solution yetu tunatokea kwenye formula from frictional force which is equal to coefficients of kinetic friction times normal reaction. So the coefficients of kinetic friction is 0.4. So we put here 0.4. we times 270. So 0.4 times 270, we get 1,080 Newton. So the frictional force itakuwa ni 1080 Newton. So my dear students, we have discussing much about types of frictional force. We are looking there is two types of frictional force, which was static frictional force and dynamic frictional force. Thereafter, we are going to looking about the frictional force at the inclined plane. We are going to solving some problems. Now it is we are going to discussing few about the laws of frictions. So in our this frictional force, it is being guided with some laws, the laws of frictions. So the following are the laws of friction. The first one, we say that the frictional force is direct proportion to the normal force between the two surfaces in contact. So the frictional force tunasema kwamba is directly proportion, ni sawasawa na normal force, ni sawasawa na normal force between the two surfaces in contact. This is the first law, whereby the K is the coefficient of frictional force. We say that the frictional force is equal to coefficient of static frictions or coefficients of friction times normal reactions. We can make subjects coefficients of frictions, whereby the coefficients of friction is equal to frictional force over normal reaction. This was the first law. The second law was the friction depends on the nature of the surface in contact. So if frictional force mara zote huwa inategemeana na nature ya surface in contact. Kwa nature of the surface ikiwa ni rough, maana yake frictional force inaongezeka. Lakini nature of the surface ikiwa ni smooth or soft, frictional force inapungua. Law ya tatu, the friction does not depend on the surface area in contact. So the friction force does not depend on size of areas in contact. It does not depend labda kwamba area ni kubwa so friction force inaongezeka. Hapana. Friction force haitegemeani na ukubwa wa eneo wala udogo wa eneo. Ila friction force inategemeana na nature ya surface. Lastly, the ratios of limiting frictions of a normal reaction is constant for two surfaces in contact. So ratio of limiting frictions of a normal reaction is constant for two surfaces in contact. So my dear students, after looking much about the types of frictions, thereafter we are discussing about the laws of frictions. Now it is task for you to go and pass and read about the states in 3 laws of frictions. So after saying so, I would like to say it was ends our period. Stay tuned at EduTV for more periods and more studies.